Intracanal instrument. Group 3 rotary instrumentation system using nickel titanium. Profile system. The profile system was introduced in 1994. The profile instrument have increased tapers compared with a conventional hand instrument. The tip of the profile series 29 rotary instrument had a constant proportion of diameter increments 29%. The cross section of the profile instrument have a U-shaped design with a radial lance and parallel central core. Lateral view show 20-degree helix angle, a constant pitch pallet-shaped non-cutting tip, and with a neutral or slightly negative rake angle. This configuration facilitates a reaming action. Debris is transported coronally and efficiently removed from the root canal. The preferred speed is 275 to 325 rotation per minute. Profile GT files. The crater taper files was introduced in 1994. This instrument also has the U-shaped file design. The instrument comes in 4 tapers, 0.06, 0.08, 0.10, and 0.12, and the maximum diameter of working parts coronally is 1 mm. The instrument have a variable pitch and increasing the number of roots in proportion to the tip. The apical instrument diameter is 0.2 mm. Instrument tips are non-cutting and rounded. Pro-taper universal system. The pro-taper system is based on another concept and composed of 6 instruments, 3 shaping files and 3 shape finishing files. This set is increased by 2 larger finishing files and a set designed for retreatment procedures. In cross section, a pro-taper shows a modified K-type file with a sharp cutting edge and no radial lance. This creates a stable core and sufficient flexibility for the smaller file. The cross section of the finishing file F3, F4, and F5 is slightly relieved for increased flexibility. The difference in design of this system is the varying tapers along the segment long axis. The 3 shaping files have tapers that increase coronally, and the reverse pattern is seen in the 5 finishing file. Shaping file ISO1 and ISO2 have a tip diameter of 0.185 mm and 0.2 mm respectively. 14 mm long cutting plates. The diameter of these files at D14 and 1.2 and 1.1 mm respectively. The finishing file from F1 to F5 have a tip diameter of 0.2, 0.25, 0.3, 0.4, and 0.5 respectively between D0 and D3, and the apical tapers are 0.15, 0.08, 0.09, 0.05, and 0.04 respectively. The finishing files have a rounded, non-cutting tip. The convex triangular cross section of the pro-taper instrument reduces the contact area between the file and dentine. The greater cutting efficiency of this design has been improved by balancing the pitch and helix angle, preventing the instrument from threading into the canal. Pro-taper instrument can be used with a 215 to 300 rotation per minute. 2 usage characteristics are recommended for the ProTaper system. Number 1, the preparation of glide path. Number 2, the use of more lateral working stroke or brushing. Such a stroke allows the clinician to direct larger file coronally away from the danger zones and counteract any treating in effect. Rays and biorays. The rays was manufactured since 1999 by FKG. The name stands for reamer with alternating cutting edges. This design aimed at reducing the tendency to treat the file into the root canal. The gross sections are a triangle or square for universal .02 instruments with the size universal 15 and 20 tips. The surface quality of a raised instrument is done by alcato polishing. The tips are rounded and then cutting. The twisted file. In 2008, the first flute nickel titanium file was introduced and manufactured by plastic deformation, a process similar to the twisting process that is used to produce a stainless steel K file. This is done when the thermal process allows twisting during a phase transformation into the R phase of nickel titanium. The instrument is available with a size ISO 25 tape size only, in taper .04 up to .12. This production process results in superior physical properties. Wave 1 Single File Reciprocating System. This system is a single-use, single-file system to shape the root canal. In most cases, the technique only requires one hand file followed by one single wave 1 file to shape the canal completely using the reciprocating motion. The file is made with M-wire technology, which improves strength and resistance to cyclic fatigue, about 4 times the traditional rotary nickel titanium file. The system is composed of number 1, the wave 1 small file. It is used in narrow canal. The tip has ISO of 20 with a continuous taper of 6%. Number 2, wave 1 primary file. It is used in majority of the canal. The tip has ISO of 25 with apical tapers of 8% that reduce towards the coronal end. Number 3, the wave 1 large file. It is used in wide canals. The tip has ISO of 14 with apical tapers of 8% that reduce toward the coronal end. The instruments are designed to work with a reverse cutting action. All instruments have a modified convex triangular cross section at the tip end and convex triangular cross section at the coronal end. This design improves instrument flexibility. The variable pitch flutes along the length of the instrument improve its safety. ProTaper next. This system is composed of 5 files, namely X1, X2, X3, X4, and X5. These files correspond to size 20 tapers .04, 25 tapers .06, 30 tapers .07, 40 tapers .06, and 50 tapers .06 respectively. The X1 and X2 have a variable taper design, whereas X3 to X5 files have a fixed tapers from D1 to D3. Then the decreasing percentage taper design of the rest of their active portion. This system has a rectangular cross section that is off-centered, which allow 2 points contact with the dentine walls and the rest of the space free for storing debris, which will be removed by the file switching motion. Group 4 Engine driven 3-dimensional adjusting file. The self-adjusting file represents a new approach in the file design and mode of operation. The file is Hello device designed as a cylindrical of thin walls, delicate nickel titanium lattice with the lightly abrasive surface. An initial glide path is established with a ISO 20K file to allow the insertion of the self-adjusting file. The file is proposed to be compressed from it is 1.5 mm in diameter into dimensions equivalent to those of ISO 25K file. The handpiece generates in and out vibrations with a 5000 vibrations per minute and 0.4 mm amplitude. The compressed file will adapt itself to the root canal walls, applying a uniform cutting action, gradually removing a uniform dentine layer from the canal walls. There a continuous flow of the irrigant which remove the tissue debris and dentine powder generated by the file. Group 4. Engine driving, reciprocating instrument, Indo-Ease reciprocating files. The gear automatic handpiece rotary instrument is used since 1969. Delivers 3000 quarter-turn reciprocating movements per minute. Rasps and barbitibros are the most often used in the gearomatic handpiece, but K-type and H-type instrument also can be used. The Indo-Ease file system is a recently introduced addition for gearomatic handpiece. The set has four instruments that are designed to clean the middle third of the canal. The sizes and tapers are ISO 10 with a tapers of 0.025, ISO 13 with a tapers 0.35, ISO 13 with a tapers 0.45, and ISO 13 with a tapers of 0.06. The use of stainless steel hand instruments is suggested for the apical third of the canal. Group 6. Sonic and ultrasonic instruments. A very different way of instrumenting root canals was introduced when the file or ultrasonic tapes of different sizes and shapes were activated by electromagnetic ultrasonic energy. Piezoelectric ultrasonic units are also available for these purposes. These units activate on oscillating sinusoidal wave in the file with a frequency of about 30 kHz. Two types of units, ultrasonic and sonic, are primarily available. Ultrasonic devices which operate at 25 to 30 kHz, including the magnetostrictive and a piezoelectric. Sonic device operating at 2 to 3 kHz. Ultrasonic device use regular type of instrument like K files, whereas a sonic device use a special instrument known as VCP sonic, shaper sonic, triosonic, or helisonic files. Although similar in function, piezoelectric units have some advantage of the magnetostrictive system. For example, piezoelectric device generate a little heat, so no cooling is needed for the electric handpiece. The magnetostrictive system generates considerable heat, and a special cooling system is needed, in addition to the irrigating system for the root canal. The file in an ultrasonic device vibrates in sinus wave-like fashion. A standing wave have an area with maximum displacement, anti-nodes, and area with no displacement, nodes. The tip of the instrument exhibits an anti-node. File must be used only for a short time, must remain passive with the canal, and the power must be controlled carefully. Ultrasonic devices have proven very efficient for irrigating root canal system. During free ultrasonic vibration in a fluid, two significant physical effects are observed: cavitation and acoustic streaming. During oscillation in a fluid, positive pressure is followed by a negative pressure, causing impulsion. This is cavitation. Acoustic streaming creates a small, intense circular fluid movement around the instruments. Thank you for your nice listening. And if you have any question, you can ask in our classroom in internet. Thank you.